everybody. Good day. Happy Wednesday. We are here at J4K, and I am here. Oh my goodness, it's the best Java ever. I'm really wound up, you can tell. I'm Erin Schnabel. I am a creator of crazy, ridiculous things at Red Hat. I got suckered into doing this keynote, which is great. I have a couple things that I would like to start with. Next 30 minutes, I don't think I'm going to go in depth necessarily with anything. What I am going to do is, like my grandmother used to say, I'm going to wet your whistle. There's all kinds of cool things going on. Some of them maybe you already know and are excited about. Some of them maybe you haven't thought about. Maybe I'll hopefully get you excited so that you'll think about it more, which would be excellent. The titles for some of these slides are random. I will totally say that for those of you that struggle with the blank slide syndrome, slide generators, the title generators really like help you procrastinate and crack you up and help you, decide what to write your talk about. So some of the titles will be hilarious. I hope you're amused. One thing I would like you to do, because we're here, because I'm actually live, right? But you guys are all sitting at your screens. This is like the one time you're allowed in a keynote to like talk while I'm typing. So please get into chat. And as I talk with this, I know all of us are opinionated, type and type and type, and have arguments and all that good stuff because you can. It's great. So please take advantage of the format. Let's go. The truth is, look at these clickbait titles. They're so great. You are not the only person concerned about Java. For those of us who have been using Java since, the beginning times, we went through a slow period there. And all of us were kind of sad because it looked like Java was slowing down, right? And some new languages were coming and it was getting a little concerning. And then somewhat recently, last year, Python started eking up into number 2. And it was like, oh no, is Java going to die? There were some interviews that came out with the 25th birthday of Java. And if you notice, I have some footnotes here at the end of the deck. I do have links to all of these interviews because some of them are really good. And if you haven't read them, I highly recommend that you do. Brian Gates had some interesting quotes because he started talking about how it was pretty clear in that slow period, right, that Java was falling behind. We had some new languages that were really doing new things. And the introduction of lambdas in that case was the big chance to prove to everybody that Java was still a thing, that it could still be taught how to do new things. It was still relevant for all these new workloads that were coming up. And what they did for how they introduced lambdas and the thought that went into that process was, I think, really interesting. If you go and read that interview, it's worth your time. Oracle in that slow period also consulted with a technology research firm, to go and look at what Java would have to do to remain competitive. So those of us who really love Java, we kind of think within Java. Java's the best. Java's the only thing. Why would you use anything else? But if you look at the bigger picture, languages like Go, like Rust, and those are the two that are probably the most in my space right now, but we know there's others, right? In order for Java to remain competitive and relevant as the workload landscape changes, right? What does Java have to do? And that report is also publicly available and is a very interesting read. I've pulled out a highlight here, right? Which is in their view, Java needed an ongoing series of innovative, must-have, delightful features that make Java, the language, right, even more user-friendly and cloud-capable. This is the genesis of the improved release cycle that we now have. And it looks like if there's some proposals now to make that release cycle actually even a little faster, where it's every other year instead of every third year. And I know there's some of us who are like, that's too fast, nobody's gonna keep up. But there's a bigger picture that people have to realize, right? There's one part of us who's like, well, enterprises are really slow. But if we keep Java at that enterprise slow pace, it will make itself obsolete because everybody else is moving way faster. And Java needs to continue to improve. And the increased release cadence, I think, has really helped us get our hands on some really cool stuff faster than we would have before. And I think it's excellent. Did it really work? Did these changes work? And just last quarter, the most recent language rankings from Redmonk, Java was back in second place, tied with Python. But what I thought was really nice was what Stephen O'Grady said. And I think this is true as someone who loves Java and has used it forever and believes in the language as a really capable language. I like that he highlighted that the language continues to be a workhorse and has consistently been able to find new work to do. And I think it's a testament to the improved cadence and the more frequent now release of features, the more incremental release of features, that Java is showing a remarkable ability to adapt to this rapidly changing landscape. This to me was awesome. It was a great acknowledgement of what makes Java a super language. Now, why does Java succeed? This is another thing that these interviews that came out with Java's 25th birthday were great, right? I love that all of the people working on the language and the JVM, they are laser focused on a couple things. So like we all have our laundry list of what we wish the language would do. It should do all the things. But they're like, the language only should do what it absolutely has to do, what libraries can't do, right? What can't be done outside of the platform. That's the only thing that the Java language should do. And Brian Gates again weighs in. He's like, the thing that has kept Java going is the relentless commitment to compatibility. Now, why does compatibility matter? The best way to Java. This is great. So the language features, those things that they do bake into the platform, they're all about enabling the rest of us to write crazy, insane libraries to do awesome things. And when we think about compatibility, what that means is our investment, the community's investment in these libraries is never wasted because we don't get to the next version that breaks everything. We keep moving forward, our libraries keep evolving as the platform keeps evolving, but everything keeps working. So we don't end up like wasting our time trying to make some awesome library. Now, this is also, I think, what powers the ecosystem is that we, right there, we want to solve hard problems and we want to compete for who has the best solution to the problem. So for those of you in chat, please start listing, because I know you can think of some without even thinking very hard, of where we have awesome libraries that are basically in competition with each other for who can do things the best. There's a bunch of them. And it's great because it really helps us advance the language. It helps us solve problems better because we can see different approaches. It's also a trap because we love to compare things. Benchmarks are our jam. We love saying this library behaves better than this library, or this one gets better throughput than this one. It's like part of our community is how we do these benchmarks. But do we know right now, with how much things are changing, do we know what the best is anymore? Do we know how to measure it? Matt let me use this tweet, and thank you, Matt. And I'm highlighting this for a few reasons. Matt is great. He is really talented, and he made a really easy mistake to make when he was doing some performance comparisons between some of the frameworks that we have right now as we're all experimenting with native. And it's so easy to do, right? He started comparing the resource utilization and startup time of operating system native processes with a Docker process. And Docker, of course, reports its resource utilization differently. And the way you're issuing commands in order to start and stop your servers, it's not always obvious that that's happening. It's a really easy mistake to make. In my view, this is an example of gracious professionalism. And Matt is a model person right here, so I can't give him enough kudos for his response. But the question that I have is, how do we not make these mistakes? Because they're really easy to make, right? Everybody wants to show their numbers. We've got a couple benchmarks right now that are really, we're all going after them. And I think the way we avoid mistakes like this is by being super transparent, right? We have to make sure we're comparing apples to apples. And in this case, right, it was the Docker view of resources, the container engine's view of resources versus like a native platform view of resources. We also know, for example, and this came up in Matt's blog post too, that different frameworks have, they make choices very deliberately. Two frameworks that I know of that I've worked on make choices about eager initialization versus lazy initialization. They make them for very deliberate reasons, but when you're measuring startup time, that matters. So the question is to be transparent. How am I what do I consider started up, right? Is it when I get the message that says it started, or is it first response, like the time we get first request, first response? That actually matters. The other thing with showing our work is we are all experimenting with native images right now. There's lots of cool new switches and options and optimizations that we're trying and approaches for how we're optimizing things for build time or runtime. We're all experimenting. Explaining why is almost more interesting than explaining the result. Why did you try these things? Why did you opt for these options? Why is really cool. Although I will acknowledge that the results do absolutely make for better clickbait. I do have, as part of this, if you'll notice, I have a link to a blog post that the Quarkus team posted where we explain our methods, how we're measuring performance, how we're measuring resource utilization across, Docker containers and other things. So, so we're being transparent. When we publish metrics, measurements for performance, here's what we're doing. And that way, when we post things, you guys could all do it yourselves and come back and say, well, I'm seeing different things. How come, why is that? And we can figure it out. And everybody wins. So there's another aspect. I don't want to spend as much time or much on Java. And that's a different way to think about performance, is to think about how much it costs. How much does it cost for you to run the same workload in different environments? And there's things that we're doing that can produce some counterintuitive results. The fact that your processes don't run as long as they used to, how densely you're packing your instances on certain platforms, how much resources have been allocated to your instances. All of these things can change the behavior of the runtime on the target platform you're deploying to. And sometimes it goes against your intuition. If we look at a couple examples. So the prevailing wisdom, for example, is if you're going to take Java workloads and put them into a serverless environment, if that's Knative or Amazon Lambda or whatever else, that a native image is going to perform better because it's smaller, right? It'll have better startup time, smaller footprint. That's the way to do it. Except there's one provider environment that has baked their JVM image into their platform to the extent that when you're deploying Java workloads that way, it's better to use their image. You will get better startup time and smaller footprint if you use their image than you will using anything else, your own Java image or a native image or anything. So you got to measure. You can't just assume you know what that answer is. When we think about resource utilization and we're measuring performance, there's some caveats there. I might take a native image by itself with certain resource utilization constraints, because that's usually how we deploy things, and it might not perform so hot. You might be able to get way better performance with a JVM image than a native image on its own. Okay, but how do we usually deploy this? If you were going to deploy these into a cloud environment and you allocated the same resource footprint, right? But then we start looking at horizontal scaling with density. So if you have lots and lots and lots of little native processes using the same amount of memory as that one JVM, for example, you'll get better throughput with the native ones because there's more. That's the premise of horizontal scaling, is you just add more. And so that requires measurement, right? It might go against what you would normally think. And maybe for some of you, this is obvious and you can be typing in chat, oh my gosh, this is so obvious, which is great. But for some people, they won't have thought about this yet. So, be gentle. We're all learning. Another thing that I think we don't think about all the time, or we have habits, is related to our garbage collection algorithms. We've spent the last 20 years optimizing garbage collection algorithms for gigantic heaps on JVMs that live forever. Those are the dinosaur monoliths that we try to say we don't want to use anymore. So do we need the same garbage collection algorithms anymore? Like, what if we're running something that's, has a really tiny heap and lives for 6 minutes? We should be able to have totally different algorithms for that, right? Do you know what they are? Do you know how you would pick one? Do you care? That's a good question. Life is interesting right now with Java. There's so many choices. So we'll talk really briefly about Reactive because of Loom. And I love Brian's go get 'em attitude with this. Project Loom will kill reactive programming. He comes right out and says the thing. Ron is a little more nuanced. And I like how he explains it. He's like, the problem with reactive programming is it pretty much breaks everything. It breaks our brains, it breaks our tools. We can't follow stuff anymore. And so what Loom is trying to do is solve the problems that reactive programming is trying to solve, but in a way that's more harmonious with the design of the Java platform. And there's actually some really great interviews with Ron where he's trying to explain what Loom is. And you can understand why they're pretty excited about how this is supposed to work. I had Clement kind of try to explain this to me, and he has a really nuanced view about this. And Clement, if you're on, you can be typing and saying, I slayed this, that's fine. He tried to say there's layers here, like that. Fundamentally, what we're trying to do, in some cases anyway, is we're trying to better take advantage of non-blocking I/O provided by the operating system. And somewhere in these other layers, we have to write messy code to handle the non-blocking nature at the OS level. So we just have to, that complexity, that stuff has to live somewhere. So the question is, where does it live? When Loom comes out, right? Loom is, if you remember what that is, Loom is taking it's putting a variant on the existing my brain just went away. Virtual threads, right? It's taking the normal notion of threads and it's defining virtual threads. And the thing with virtual threads is that the language definition already gives us a lot of permission. If you think about how our concurrency libraries are defined, if you think about how our the locking mechanisms are all defined, the language already gives permission for us to context switch all the time, whenever we want, unless we have a critical section defined that says you can't switch threads. So the mechanism exists for virtual threads to really come in and be much lighter weight and just context switch all the time, which means we actually can carry this context along, which fits our model, our mental models better. Our tools will be able to follow stack traces. I can totally see why the people working on Loom are like, no, this is going to be way easier than reactive programming, which really breaks your head. And I think Ron is right. There's going to be plenty of developers who prefer using virtual threads to get better throughput. Clement has a different, or has an additional view on that, right? Which he says, when Loom comes, like with people even starting to use virtual threads, it's going to make it easier for us to do some of the other reactive patterns. And what we might end up with is that the real reactive programming style is going to be used where it's really needed, where you need to be able to handle things in a way that deals with back pressure, for example. And you won't just use it everywhere you want to do better non-blocking I/O. And I think that's an interesting take. But what will be the next couple years, right, as we wait for Loom to really roll in, how we handle this reactive landscape is an interesting problem space in and of itself. And if you haven't been looking at what's going on, I encourage you to do so because you'll learn a lot. It's pretty interesting. More stuff about Java that you probably hadn't considered and really should. Remember, this is a wet your whistle talk. How are you building your Java images? Are you using Docker? Do you still like Docker files? Have you flipped over to using Jib or Fabricate, where it's just part of your Maven POM file, for example? You don't actually write the Docker file. You let something turn your Java application into an OCI image for you more directly without using Docker in the middle. Have you looked at Builda and Podman as a replacement for Docker now that Docker has decided to charge us all $1 billion? Have you heard of cloud native build packs? Do you know what those are and what those do and the value that those bring, not just to you as an individual developer, but to your team, to your larger organization? If you haven't looked at those and understand what those are doing, that's also a really interesting thing to look for, because cloud native build packs are trying to help you build consistent images in a way, right? Let's make sure that we're all following the rules and we're all getting all the updates that we need to get. So that's all cool too. Another really interesting space is OpenTelemetry. That's hot right now. I'm involved in it. I've got other people that I'm working in there with. We've got well-known library maintainers that are working with the OpenTelemetry community to make sure that Java has good representation, has a solid implementation. The interesting thing to me about OpenTelemetry is that the initial participants in the Java group tended to be monitoring library providers. Datadog, Instana, New Relic, right? All of the people that are providing the instrumentation agents that a lot of us just turn on and the magic happens and metrics come out. Like we don't know what it does. But instrumentation starts to be like the traditional instrumentation agent starts to be really interesting if we're talking about native images, because instrumentation, right, it looks for familiar hooks in the code to get its little tentacles in there and to do the instrumentation and collect the measurements, and that's how it does it transparently. Okay, so if you're going to a native image, those hooks might not be there at all because the code, I don't know, may be gone. Or in the case of Quarkus, we may have changed what that looks like a little bit. And so there's an interesting, how do we make sure that these open telemetry agents will work well in the case where we want to do more at build time and then some at runtime? How do we make sure that the agent can focus, that can still fit in that model? That's an active, place where we're exploring. It's in a way, a non-trivial problem. Like there's some interesting caveats there. And so if you have an interest, please join that community. They're very welcoming, and participate, test it, try it, contribute. It's all great. Another place that's really cool for those of you that like JFR, I know a lot of you really do. Another question we're exploring is the intersection between OpenTelemetry and JFR, where JFR is more focused on profiling. OpenTelemetry doesn't really cover profiling, but at the same time, OpenTelemetry or JFR can emit really good metrics. So should some of those metrics go into your OTLP flow? I don't know. So that's an open question, how we pull some metrics from JFR and event streams and forward those on, versus whether or not there's a whole new space that should exist in OpenTelemetry for continuous gathering of profiling data. Like those are open questions, super fascinating. There's plenty of room for participation. Please, if you have an opinion, if you find it interesting, jump in, water's fine. And then there's this question, are you actually doing enough Java? So we have all of the existing Java workloads that we know. You already know how to write UI applications. You know how to write app servers. Those are not dead yet. They're only mostly dead. They're still chugging along, doing their thing. Within the self-contained application line, where we're talking about applications that can go into containers that get deployed into Kubernetes, we have a multitude of frameworks, even more now than we did a couple of years ago. And I actually really like how many there are. And I like that they're taking slightly different approaches in some cases. I think it helps break our assumptions about how things should be done. I'm all about that. And so if you haven't tried some of these, if you haven't heard some of these, go look at them, go look at what they did. Like Pyara, I think, has a very different way of I think they've defined an operator that lets you take your war file and you give it to an operator and that runs it in Kubernetes. So you don't even have to just this is so different. Although the interesting thing about that one is it really does hammer the point home that the new app server mothership is Kubernetes, right? For those of us who haven't caught on to that memo, we're back to Corba, but with Kubernetes. There's lots of things to try there. Try them all. Try them all. Make sure you've tried them all. Make sure you know what they are, because they all do things a little differently, and it can really make you think about why things work the way they do. Native images are really opening the door for all kinds of new things. Like command line applications that actually feel like command line applications that get down to a little binary and you just run them and they have arguments. Pico CLI is great. You don't have to use Pico CLI, but let me tell you, it makes working with your arguments way easier. Parameter parsing and like help that looks like help. It's really nice. And for those of us that know the language very well, I don't know that I'm good at switch to Go to write a command line app, but I can write it in Java, build it to native, and you won't know the difference. Perfect. Totally look into that if you haven't. There are people also with compile to native that are starting to look at writing Kubernetes operators in Java. There's a new operator SDK you can go check out if you are into writing operators. And that works fine also. Now, the most crazy thing I have heard of recently, I was doing a Quarkus World Tour in Seattle. I was floored and amazed, and I thought it was great. I don't really know. Somebody took a Java application. They wrote an XML parser compiled it to native mode, and added it to their service mesh as a filter. So for those of us who know all of the XML routing stuff that happened with SOA, you should all be twitchy right now. Like, oh my God, I can think of a couple of really expensive appliances that this just replaced. And oh my God, like my head just broke open. Like, seriously, you did that? But Java is great with XML parsing. It's got some really great libraries that help you do that, and they can be really performant. And now you're writing in what you know to get functional XML routing decisions made in your service mesh if that's what you need to do. I think that's brilliant. I was really excited about that. 10 ways to reinvent your Java. Martin is talking at the end of the day about all the cool stuff that's just in Java 17. Please go to that because there's some stuff. I mean, I love his enthusiasm. He used almost as many exclamation points as I did. There's some stuff in Java 17 that's really cool. One of the things to tie back to that Oracle report, the report earlier, was they had an encouragement for Java to focus more on machine learning and AI workloads. And one of the things that's kind of in the way for Java is how we process data. And I know a lot of you are going to be like, what are you talking about? We totally process data just fine. I don't know what you're talking about. The conversion stuff that we have can be a little heavy in terms of the conversion to and from POJOs and, you know, private fields. And I mean, I've had enough arguments just in the last month about how you should or shouldn't be defining your POJOs so that Jackson and stuff could use them. And then we've got the other Jackson, JSON, BNP. There's 4 or 5 ways to do this. Records are going to be real fascinating. So if you have never heard of that, please show up to Martin's talk and learn about that, because I think that's going to open some doors that we need to have open for Java, and that's going to be exciting. So do that. One more question. I'm actually going to finish early because I went really fast. This always happens. One question you don't want to ask anymore. Which build tool are you using? We don't have to fight about that anymore because all the answers are correct. As long as your org agrees, it's fine. But I do want to mention, if you haven't tried JBang, and there's a link, of course, in the doobly-doo, as Matt Colville would say. JBang is pretty cool. Max has been working on that a lot. What I kind of like about it is there's like different pieces to JBang. So if you're writing code, like if you want to use it to write the equivalent of a shell script, it's real scrappy, throws out all the rules. You don't have to use capital letters. You don't have to do imports. I mean, like it's just like he's breaking it on purpose just so you can think differently. I love it. It's so fun. But if you don't like that and you want to write your stuff normally, JBang still makes it a lot easier to consume a jar file. Like you don't have to write your alias. You don't have to fuss with the command line on like manually. It figures it all out for you. And it makes working with little utilities you might write in Java more interesting and more fun and easier. So if you haven't tried JBang, please go play with it. I think it'll open some doors for you in terms of what you might use Java for just while you're tooling around. And I think that's a really good thing. So wow, 2 minutes left. I told you I had to hit 30 minutes on the nose. So we can flip over to Q&A early if we want. Or I can just have these. Okay, let me see. How has the pervasiveness of the cloud changed Java? Oh, this is great. So I think we are still, as a large community, processing that. We're still trying to adjust to what the prevalence of the cloud really means. And some of the stuff that I mentioned earlier about how we think about garbage collection, about how we think about tuning, like we're not all the way there yet. And I still see a lot of people, how you change backing services, how you make sure your configuration can be injected, all of the usual 12-factor principles. We're still digesting all of that. But I think the prevalence of cloud resources, it really changes how we create and build and deploy our apps. It's going to change how we think about resource allocation. It's going to change how we deal with garbage collection. And I think we're still digesting that. I mean, I can't emphasize enough, right? As someone who worked on WebSphere, the big one, and worked on Liberty, the little one, the change that we're seeing as you get from the big to the less big to the now teeny tiny native image, it's so different. And a lot of people they haven't really wrapped their heads around the differences here. This is a good question. If a cloud provider offers an optimized VM image that runs Java very fast, why would an organization still want to use a native image? And that's a great question. And it may not have a super straightforward answer. I mean, if you're going to if that's your target, do it. Stick with JVM, go for it. I mean, there's no requirement for you to use native. And that's, I think, I think there is a little bit of a, native is like, it's a little bit of absolutism, right? Your target doesn't have to be native for everything. But if you want to use Java to write your own operator, or you want to use Java to write your command line utilities or utilities that you're going to use in your build system because you know the language really well, do that, right? Maybe you're not going to native mode for your thing that's running in production on the environment that has the tuned JVM image. It's great. There's no one answer. The best part is that you're at least using Java all the time. I mean, that's the important part, right? You're sticking with a language that you know, with practices that you understand, with build tools that work well, so you can get that kind of consistency and then still use all these different target environments. With so many Java frameworks that optimize, do I have recommendations as to when to use each? This one is interesting. I mean, sometimes it's preference, right? It's what you know, what your org knows, what your organization knows, what your collective knowledge is, right? There's a whole population of us that love to always do the new thing. We're the first ones in the room to test the new thing out. But when you think about future you or future newbie who has to know what you did, some of the recommendations for what frameworks you use, like there's some notion of how are we going to sustain this long term? What kind of framework gives us the best continuous update? Oh, that's another thing. Have you guys thought about how you're going to maintain things over time? There's some new things coming out. Go look at Open Rewrite. And the reason I'm talking about Open Rewrite specifically as an open source project is because it's not looking at big bang migration. Like there's lots of really awesome migration tools that will help you make that jump from an application you already have to like a one that's formed in a new way. Open Rewrite is literally about continuous update. How do I keep my stuff current all the time? Every time a migration, like every time I get a new version of a runtime that might have some things to change. That goes for Spring, it goes for Quarkus or Micronaut or whatever. Anybody's got a change log, right? If you need little minor changes, how do you automate making those incremental changes so you keep up? Oh, that's such a big question for cloud computing, right? And when we start thinking about all the secure, like our secure source, why am I not remembering that word? It's gone, but you guys know what I mean. But when we're looking at the security of our source code and how we stay current and avoid CVEs and all that stuff, like that continuous migration, continuous compliance, it's such an interesting question. And there's some new project coming out. Open Rewrite is the one that I know the most about that are going to help us do that. And I think that's amazing in terms of keeping an eye on Java frameworks that help you stay current in this cloud environment. Okay, so Project Loom, there's some comments too about Project Loom with messiness of your code. So for sure, if you're the nice thing about Loom going to virtual threads is that it will allow us to just write our multi-threaded code the way we always have. Because again, the language already has permission to context switch whenever it wants, unless we tell it it's not allowed, which is a much better position to be in. So in that sense, async code would be more imperative. And I think we should be able to see, we'll have to see how the libraries react when Project Loom becomes available, right? Will async JAX-RS or async servlets suck less because we won't have to use the stupid future things? I mean, will we even need those? Because we can just make the normal JAX-RS paths and stuff be non-blocking. I mean, that's what we're after most of the time is non-blocking. And I think I'm at the end. So Caesar, thank you guys for coming. Chat lots.